have an applied problem here in fisheries. It says the total groundfish population on Georges Bank in New England between 1989 and 1999 is approximated by the function, and I have it written down there. F of t equals 5.30 t squared minus 53.977 t plus 253.8. Now this function is calculating the total metric tons of groundfish at time t equal to somewhere between 0 and 10. T equals 0 corresponding to 1989, the beginning of 1989. T equal 1 corresponding to the beginning of 1990. T equal 2, the beginning of 1991, etc. Now, the first question is, what is the rate of change of the groundfish population at the beginning of 1994? What is the rate of change of the groundfish population at the beginning of 1994? Well, to answer a question, a rate question, or how fast the groundfish population is changing, I'm going to need a derivative function. So I'm going to apply the rules in this section to calculate a derivative of my function, and multiplying the 5.303 by 2 I get 10.606, dropping the exponent by 1, and then my next term's derivative is just simply 53.977. So I have a derivative function, and to evaluate this for 1994 I'm going to let t equal 5. Notice the pattern there. And I get a negative 0.9 for that. And now what does that mean? That means in the beginning of 1994, the rate of change, first of all, is negative. And the function is calculating the total metric tons. So this is a negative 0.9 metric tons of groundfish per year. Notice the per year there. So I would have that the groundfish population, I could say the groundfish population is decreasing at a rate of 0.9 metric tons per year. Now notice what would be f of 5 if I went back to the original function and calculated or evaluated that at 5. Let's see what that is. So at the beginning of 1994, there is 116.5 metric tons of groundfish. So remember, the original function calculates the total metric tons of groundfish. It's a count of how many. The derivative function calculates how fast that amount is changing. And at the beginning of 1994, I have 116.5 metric tons of groundfish, but that amount is decreasing at a rate of 0.9 metric tons per year. Notice the units. The units is metric tons for the original function. For the derivative function, it's metric tons per year. It's a rate. The derivative is calculating a rate of change. How fast is the population changing? So again, at the beginning of 1994, I have 116.5 metric tons of fish, ground fish, but that's changing at a rate of almost a metric ton per year at that point. Now, another question is what's going on in 1996, and finding the derivative for 1996, that would correspond to t equal to 7. Again, that's a rate question, so I'm using the derivative function for that and evaluating the derivative at t equal to 7. I get 20.265. So what's happening here? The ground fish population is increasing at a rate of 20.3 metric tons. Don't forget the per year, because it's a rate. So something big happened in 1996. The population of ground fish is actually increasing 20.3 metric tons per year at that rate. But in 1994, at the beginning of 1994, it was actually decreasing at about a metric ton per year. So that was kind of turned around a little bit by something. In part B, it says fishing restrictions were imposed in 1994. So at the beginning of 1994, the number of ground fish was decreasing at a rate of about a metric ton per year. But then at the end of 1994, there was a fishing restriction, so that by 1996, the process of that population decreasing in size was actually reversed, and now it's growing at a rate of 20.3 metric tons per year. So that's quite a bit of change. As a matter of fact, let's calculate how many ground fish there were at the beginning of 1996. Now that kind of question, again, I'm going to use the original function because I'm asking how many ground fish were there at the beginning of 1996. So I'm going to evaluate the original function 7, and I get 135.8 metric tons. Just metric tons, period. So at the beginning of 1996, I've got 135.8 metric tons of ground fish, and that population, that amount, is increasing at a rate of 20.3 metric tons per year. Whereas in 94, I had 116.5 metric tons of ground fish, but it was decreasing at a rate of 0.9 metric tons per year. Again, a thing I want to point out here is that keep track of the function. When you're looking at a mathematical function representing the relationship here between two variables, in this case time and the total ground fish, the original function is calculating a total amount. The derivative is calculating a rate of change. So this is kind of a nice problem to illustrate the differences between these two functions. And think about this carefully. And again, also notice the units. The original function is calculating total tons of metric ground fish, but the derivative is calculating tons per year, a rate, how fast it's changing. Remember, the derivative is a slope, a rise over run, a change in the functional value with respect to its independent variable. So be careful to keep the units straight, keep track of what the functions are giving you.